I hope it's visible, right?
Yes, sir, visible.
Okay, perfect. So, good evening, everyone. This side, Dr. Abhijeet. This side, Dr. Abhijeet. And today, yeah, this side, Dr. Abhijeet. And today we are going to discuss, the lipid biochemistry part two, right? The metabolism of lipids part two. So, yes, before that, some features about the Oracle app, guys. You already know we have started a program from June 1st, and where we are doing rapid revision of all the important questions, all the potent questions that are no important for the upcoming exam, your university exams that are going to be held in August. Apart from that, I will be revising the most important topics in a very quick, crisp, and concise manner, right? So all the high yielding topics which are no expected, and all the expected topics are being covered in these sessions, right? So it is beneficial for all the first year students, right? uh, okay, and yes, it is also beneficial for the NEET PG students and the FMG students. Apart from that, guys, you already know the core features, right? We have the live classes that I'm already taking with you, and it is on air, live on YouTube as well. Apart from that, there are recorded classes that are available in the app. The notes are very, very important, and know the first year students, like they are mostly after these notes, and the notes are curated in a very no they're curated in a very like good manner, I would say. It is in the form of a Q&A form, right? The question and answer form. That is what is being asked in your exams. Apart from that, guys, after each and every topic, we have certain MCQs based on those topics, which covers all the PYQs and the previous year topics as well. And we have some clinical questions allied to this, right? In addition to this, we have clinical questions and the most expected questions that can be asked in the upcoming NEET and FMG exam. Now, guys, you already can see the plan over here, a 3-month plan, the 6-month plan, and the 12-month plan. Apart from what the amount has been shown on the screen, you can avail some extra amount discount on your particular purchase by using my code, that is Dr. Abhijit 20, for additional discounts, right? So before wasting much more time, let us just start with the lipid metabolism part one. We have already discussed the biochemistry of lipids part one and part two. So today we are going to discuss the lipid metabolism part one. And first, in like a 10 marks question, I would say I am going to discuss the process of lipid digestion in detail, guys. Apart from that, we have short Q&As, right? So these 5 questions I will be discussing in addition to this long question. So without wasting much more time, let us start with the process of lipid digestion. Now, these notes are just from the Oracle app, guys. You can easily find these notes on the Oracle app. You have to download it from the Google Store, right? The Play Store. Okay, I'm saying the Google Store, the Play Store, guys, right? So yes. Now, guys, whenever we say lipids, guys, we have the 3 macronutrients in our body, and the most important one you can see over here. Okay, let me just try it. Yeah, we have this lipid, guys. We have this lipid. Now, the very first one. Now, when we say digestion, guys, basically means the conversion of big molecules into small molecules, right? That is something over here. It is called as emulsification. Emulsification. So that is the first first step that is occurring in the lipid digestion. It is emulsification. Now, guys, you already know we have something called as triglycerides. Okay, we have triglycerides, or it is also called as yes, triacylglycerol, right? Triacylglycerol. This is the form in which we are consuming the lipids in our body, right? So this is the form in which we are consuming the lipids in our body. They are commonly called as triglycerides or triacylglycerol. You already know these THEs. These THEs basically they will be broken down to form fatty acids and glycerol. They will be broken down to form the fatty acids and glycerol. Now, to reach this step, now how the process of digestion is taking place, just try to focus on that, guys. Now, you already know emulsification is the first step that is basically taking place, and it is breaking the triglycerides into smaller monoglycerides. Now, when I say triglyceride, guys, means it has 3 fatty acid wala group, right? R1, R2, R3, the long hydrocarbon chain, the 3 fatty acids wala group. Now, when I say monoglyceride, it will have only one fatty acid wala group. And obviously, with the help of enzyme, which lipase, obviously, any breakdown, anything which will require an enzyme that is called as lipase. So triacylglycerol, via the action of lipase, will be converting into monoacylglycerols, right? Now, digestion of fats to lipids basically begins in the mouth. It begins in the mouth, right? And it is a chemical digestion, guys, right? It is a chemical digestion because there is an enzyme that is present in the lingual. When we say lingual means the mouth, the lingula, right? So it is the lipase. Now, this is guys, I would say the minor digestion. It is a very small part of the fats which are digested in the mouth, and that is too by the action of the lipase. It is very minor, right? Now, even if you are ingesting cholesterol, okay, we haven't discussed cholesterol up till yet, but remember, guys, if you are taking cholesterol, so you might have heard, no, in your family members that no, this person is having high cholesterol, right? So he's more prone to heart disease. So that cholesterol, when you ingest it, right? All the oils and butters that you are consuming, right? So all the cholesterol, it is not broken down by the lipases. Very important, guys. It is not broken down by the lipases. And in the mouth, there is no digestion of cholesterol. In the mouth, there is no digestion of cholesterol, right? Now, again, the digestion of the cholesterol, it will take place in the small intestine, obviously. From the mouth of cholesterol will go into the stomach. In stomach also there is no digestion of cholesterol. After stomach it will go into the small intestine. Now small intestine has epithelial cells. Over there the digestion of this cholesterol will take place, right? Over there the digestion of this cholesterol will take place, right? So apart from that, let us just discuss the steps in detail. So guys, you already know we have the minor digestion of lipids in the stomach, right? Mouth, we have already told you, mouth is also called as lingula. So we have a lipase over there, lingula. Yeah, the lingual lipase is there, which is helping in the conversion of the triacylglycerols into monoacylglycerols, right? Triglycerides into monoglycerides. Apart from that, there is minor digestion in the stomach also. There is no complete digestion in the stomach. So what is there over there? You already know over there. Yes. Over there, guys, just a minute. Yeah. Over there, it is acid stable lipase which is present. It is acid stable lipase which is present, right? Now, you already know in the stomach, we have some acid, and that is known as the hydrochloric acid, which is present in the stomach, right? Now, it is initiated by the acid stable lipase over there, right? Now, there is presence of gastric lipase for limited digestion. Apart from that, yeah, in adults, if we talk about adults, if we talk about us, so guys, in the mouth, there is minimal digestion of lipids. Apart from that, guys, apart from that, you already know from the mouth, the food, the lipids is going into the stomach. In the stomach, we also have limited digestion or the minimal digestion, guys. The minimal digestion, right? Now, where does the complete digestion of lipids take place? It is the small intestine. It is the small intestine. Small intestine. So let us come to the picture of small intestine now, right? Now, what happens in the small intestine? Now, when I simply say what is emulsification, guys? What is emulsification? Now, when I say emulsification, guys, you already know emulsifications mean breakdown of large fat molecules, right? In a very simple language, into smaller fat molecules. Smaller fat molecules, right? Similarly, the large droplets of fats are converted into smaller droplets, right? Or the lipids over here, okay? Now, how they are converted, right? We have the three different mechanism, guys. We have the detergent action of the bile salts, right? We have bile acids, bile salts, right? Surfactant action of the degraded lipids, and mechanical mixing due to peristalsis. Now, what is peristalsis, guys? You already know peristalsis means rhythmic contraction and relaxation of the muscles of the alimentary canal. Muscles of alimentary canal. You guys already know there is rhythmic contraction and relaxation of the muscles of the alimentary canal, that is called as peristalsis, and there is mechanical mixing due to the rhythmic contraction of the muscles of the small intestine and all. It is getting mixed, right? So that is somewhat aiding on to the process of digestion of lipids. Apart from that, guys, just remember. Now, what let us just try to discuss all these three things one by one. The first one, guys, that is the detergent action of bile salts, right? Now, you guys already know we have one organ that is called as the liver. In the liver, what is synthesized? Bile salts are made in the liver. Bile salts are made in the liver. They act as an emulsifying agent. Now, when I say emulsifying agent, guys, automatically this comes to your mind that they will help in the breakdown of the large fat molecules into smaller fat molecules. That is something called as emulsification. Big droplets of fat breaking down into small droplets of fat with the help of an agent over here, and that is nothing but called as the bile salts. So bile salts are acting as an agent, okay, as a helper over here to basically for the conversion from large to small molecules. Now they interact with the lipid particles, converting them into emulsified droplets, right? Now they also help in the formation of micelle, guys, right? That is something you have to remember over here. Now, surfactant action of degraded lipids. Now, you already know the triacyl glycerol will be broken down into free fatty acids, right? The triacyl glycerol will be broken down into fatty acids plus glycerol, right? Glycerol or monoacyl glycerol, right? With their phospholipid components, right? Now, the basic reaction, you already know the triacyl glycerols, they are basically formed from the fatty acids and glycerol only. So obviously the triacyl glycerol will be broken down into fatty acids and glycerol, right? Now they process both polar and non-polar groups. You already know when we say acid, guys, it is COOH. COOH. Automatically there is a charge, COO minus and H plus. So that is the polar part, right? The fatty acid, the long hydrocarbon chain, the non-polar part is also there, right? So that is again helping in the breakdown wala part, right? And yeah, mechanical mixing, I've already told you that is the peristalsis, that is the rhythmic contraction and relaxation of the muscles, and they automatically try to mix it. Yeah. So into smaller droplets, they are actually mechanically trying to compress it. And obviously these droplets are essential substrates for digestion, right? So that is something that you have to remember over here. Apart from that, we have a very important, yeah, we have something called as, yes, let me just try to, yeah. You already know we have an organ over here that is called as the duodenum. We have an organ over here that is called as the duodenum. Now, in the arms of the duodenum, guys, we have something called as the pancreas, which is located. We have something called as pancreas, which is located in the arms of the duodenum. Duodenum, it's a part of the small intestine, right? So this is also called as the romance of the duodenum, where no pancreas is trying to be in the arms of the duodenum. So that is something, a romance which is occurring in our own body, the love triangle, which you can see over here. Now, what these enzyme, the pancreas basically help in digestion. You already know in mouth we have lipases, stomach also we have gastric lipases, but they are doing very minimal digestion. Apart from that, coming on to the small intestine, we have those epithelial cells by no, they are also helping in digestion. Even the liver, we have the bile salt synthesis, which also help or act as an emulsifying agent. Apart from that, guys, these pancreatic enzymes, they are also responsible for the degradation of triacylglycerol, right? Now, you guys already know in pancreas, what will be the name of the enzyme? It will be pancreatic lipase. It will be pancreatic lipase. Now, you already know what will happen. The triacylglycerol or the triglycerides will be broken down into monoacylglycerol plus fatty acids, right? We have already discussed this in the chemistry of no lipids. I've already drawn the structures of lipids, triacylglycerol, monoacylglycerol. Just try to go through the previous lectures, right? Even the cholesterol esters are also degraded by the help of the enzyme that is called as esterase, right? And automatically the free fatty acids will be released. Even the phospholipids, right? The pancreatic juice contains phospholipases, right? That is phospholipase A2. I will be coming on to these parts a bit later, right, in the upcoming slides. So that is also helping in the digestion of these lipids. So as of now, you have to remember the process of lipid digestion. But now coming on to the different types of lipoproteins. Now coming on to the different types of lipoproteins. Now let us first understand what is meant by the term lipoprotein. This is something very, very important. And I would ask you guys to make a dollar sign over here. Digestion, obviously, you know from class 11th also, but lipoproteins is something that I believe that you guys already don't know. Now, when I say lipoprotein, guys, let us first try to discuss with me. Then I will come to the notes which is present in your Oracle app. Now, coming on to the lipoprotein, guys. Coming on to lipoprotein. Now, when I say lipoprotein, guys, it is a compound that is formed from two components. We have lipid, and we have protein. We have lipid and we have protein, right? It is a compound that is having two components, guys. It is having lipid also, and it is having protein also. Now, what is the concept, guys, over here? Why there is a need of lipoprotein in our body? Why there is a need of lipoprotein in our body? Now, guys, you already know. Let us suppose that this is our blood vessel. This is our blood vessel. Blood vessels means the arteries, right? I'm talking about the arteries. Now, arteries are carrying the oxygenated blood, everyone knows, and these arteries are supplying the blood to different parts of the body, right? Now, guys, let us suppose that this is a lipid molecule. Let us suppose that this is a lipid molecule. Lipid means fat. This is fat, right? So, lipid, if it is present alone in the blood, okay, if it is present alone in the blood, it is not soluble. Lipid alone is not soluble in the blood. Not soluble in the blood. This is something very, very important. The lipid which is present in the blood, it is alone not soluble. Now, if the lipids are attached to the proteins, if the lipids are attached to the proteins, then these lipids become soluble and they can be transported in the blood, right? Right. So lipid plus protein is only way by which transport we can transport lipid in the blood. Lipid in the blood. Now there is no other way, right? Because lipid alone is not soluble. So it is lipid plus protein. Protein is some additional factor, no, which makes this lipid not soluble, and it can transport along this blood vessel, right? That is the concept of lipoprotein. Now, guys, you already know we have the three different. So firstly, we have discussed the concept, right? Now again, if I just want to discuss the structure of lipoproteins. Structure of lipoproteins. Now, guys, there are three different structures that you have to remember. Yeah, the three different structures, or I can say, no, the three different layers, I would say, the three layers that you have to remember, right? Starting from the inner part, then we have the middle one and the outer one, right? So the inner core, basically it consists of hydrophobic lipids. Hydrophobic lipids. Now, guys, when I say hydrophobic, hydro means you already know hydro means water, phobia means it's fear. So obviously this part it will not be soluble in the water. It is hydrophobic part, right? Now, these hydrophobic lipids are nothing but the triacyl glycerol. The triacyl glycerol, or simply we have cholesterol ester. Cholesterol ester. I will be coming to this. Yes, we have triacyl glycerol and the cholesterol ester. They are constituting the inner part of the lipids. part. Now we have three layers, guys. The inner layer, it is the inner core. It is hydrophobic, means it is not soluble in water. It is not soluble in water. Coming on to the second layer, guys, lipids. Amphipathic cholesterols, right? We have cholesterol. Lipids. In addition, we actually have the phosphate group. Yeah. The complex lipids, right? The compound lipids, no? And the outermost, it is basically the third layer of this lipoprotein, which is consisting of peripheral. Obviously, the outermost, it is along the periphery, right? So we have some peripheral proteins. Yes, and we also have some integral proteins. Integral proteins like ApoB100. I'll be coming to all this, but just remember, if we just talk about a lipid, the inner core, it is not soluble in the water. The middle wala part, it is formed of cholesterol and phospholipid, and the outermost part, it is protein. That's why what the structure is, lipid covered with protein. So protein will be the outermost part. Okay, and that protein which is covering the lipid entirely from outside, it is the peripheral protein. So this is how the structure of lipoprotein is, right? Now coming on to the different lipoproteins, that is the question that has been asked in the exam, right? The different types of lipoprotein. So you already know the structure of the lipoprotein, guys, right? Now let us just try to discuss the different, yeah, and it is very, very important. We have different lipoproteins. Let us first try to make our own chart, and then we'll come to this, right? Now we have chylomicrons. And remember, guys, these are the lipoproteins which have maximum size. The second one, we have very low density lipoproteins. Very low density lipoproteins. We have very low density lipoproteins. It is VLDL. Third one, low density lipoproteins. That is called as LDL. Then we have intermediate density lipoproteins. Intermediate density lipoproteins, it is IDL. Then we have high density lipoproteins. High density lipoproteins. This is called as HDL. And we also have lipoprotein X, lipoprotein A. So these are the different types of lipoproteins. We have already discussed the concept, why they are important, what are the structure of a lipoprotein, and coming on to the different types of lipoproteins. Chylomicrons, guys. I already told you that this is something which is having the maximum size, guys. This is having maximum size. Now, what is the use of this chylomicron in the body? Now, guys, remember that it is the lipoprotein that carry exogenous, okay, or I can say exogenous, which is actually from outside, exogenous dietary, okay, the one which you're consuming from the diet. So they are consuming the exogenous, or they are carrying the exogenous dietary triacylglycerol from intestine to peripheral organs. Okay, from intestine, which intestine? Small intestine. From intestine to peripheral organs. Remember, the chylomicrons have maximum size. And apart from that, one important Viva question that they have been asking, that these chylomicrons also have maximum lipid content. Okay, maximum lipid content, right? Now that's why maximum size and maximum lipid content, they have low or least density. Now again, this will contradict, guys, why they have the least density if they're having the maximum lipid content. Now again, use your brains, guys. If the lipid content is more, automatically lipoprotein, it is made up of lipid plus protein. So automatically, if it is having more lipid, the amount of protein will be less. Now you already know one concept, guys. More protein means more density. Proteins are the structural units of our body. So automatically, if there is more protein, there will be more density. So obviously over here, they have the least density because they have maximum lipid, right? Now coming on to, yes, they have the least protein content, guys. Chylomicrons, remember, guys, they have the least protein content. Least protein content. Okay. Now, when I say maximum lipid content, means it contains maximum THE, triacylglycerol, right? Now, okay. Now, there are some apolipoproteins which are not additional to this, which is present in the chylomicrons, guys, that you all have to remember. We have the ApoB48, right? Or other, it can be no ApoC2 or it can be ApoE. Right, these are something additional or the apolipoproteins that are present in the chylomicrons. This can be ApoB48, ApoC2, and ApoE, right? So that is something you have to remember about chylomicrons. Now, guys, now when we say the very low, so we have already discussed the chylomicrons, guys. We have already discussed the chylomicrons. The things that you have to learn, it has the maximum size, the maximum lipid content that is in the form of THE, right? It has the least density because it has the least protein content. Protein, if it is more, it has more density. If it is less, it has least density. Apart from that, the apolipoproteins which are present over here, apolipoproteins which are present over here, it is ApoB48, ApoC2, and ApoE. That is all the takeover points, and you have to remember it contains the dietary THE from intestine to all the peripheral organs of the body. Now coming on to VLDL, let us just discuss in short about all these other parts. VLDL, it is very low density lipid. Very low density lipid, guys, right? Now, this is something which is assembled in liver. This is something which is assembled in liver. Now, it carries the endogenous. Now, remember what's the difference between the chylomicron and over here? That was exogenous. It is endogenous THE. That was exogenous. Exo means from outside. That is in the form of type. But this is endogenous THE from liver to peripheral organs. From liver to peripheral organs. Right? Now, apolipoproteins which are present over here, they are ApoB100, right? ApoC2 and ApoE. Now, coming on to the third one, guys, that is the low density lipids. The low density lipids, or also called as the LDLs, right? Now, these are basically formed from, again, a question, a very important Viva question. These are formed from VLDL, right? Now, what happens, guys? Very low density lipid, okay? It will convert into intermediate density lipid, and this intermediate density lipid will convert into low density lipid. So I can indirectly say that this low density lipid, it is coming from very low density lipid. Now this conversion is called as lipoprotein. It is called as the lipoprotein cascade pathway. Cascade pathway. Again, two important questions. These low density lipids, guys, remember it has maximum cholesterol. Maximum cholesterol and cholesterol esters. Cholesterol esters, right? Now, the cholesterol which is present in LDL, the cholesterol present in LDL, it is called as bad cholesterol. Very, very important. The examiner will always ask you what is bad cholesterol, right? That is the bad lipid, that is low density lipids, bad cholesterol, right? The major lipoprotein over here, it is B100, right? So she will always ask you which is the bad lipid, right? It is the low density lipid, right? And why it is the bad one? Because it has the bad cholesterol, right? Coming on to the last one, guys, over here that you have to remember, that is the high density lipid wala part. Yeah, we have the high density lipid. Now, guys, you already know high density lipid or lipoprotein, I would say high density lipoprotein. Okay. We have little lipoproteins only. Okay. Lipoprotein कर लेना यार. Lipoprotein, right? Low density lipoprotein. It is right. So the protein component also you have to write, right? So high density lipoprotein, that is HDL, right? Now, it is formed from intestine and liver. It is formed from intestine and liver, right? Now, this is okay. High density lipoprotein, it is having the function of reverse. If we just ask one function, that is reverse cholesterol transport. Reverse cholesterol transport. Okay. So again, it is very much opposite to that of LDL. Low density lipoprotein, basically, it is helping in the formation of these it is having the maximum cholesterol and all. But over here, it is basically the function of its HDL is the reverse cholesterol transport. So that's why this HDL, it is also called as the good cholesterol, right? It is also called as the good cholesterol, or they will simply ask you the good. While lipoprotein, you already know it's a good cholesterol. Now remember, why guys it is the good cholesterol? You should remember that it is having the maximum protein content, right? Maximum apoprotein, yeah, apoprotein part, right? It is having the least lipid content and least size. Again, I've already discussed, guys, whenever there is maximum protein, you already remember maximum protein directly corresponds to the maximum density, guys. It directly corresponds to the maximum density, right? So that is something you guys have to remember over here. Okay. So that is about, yes, that is about this part, right? Or even if you guys want to know that this high density lipoprotein, it is having maximum phospholipid, right? This is also something which is asked. It is having maximum phospholipid, right? It is having maximum phospholipid. So that is something you have to remember. Again, it contains ApoE and ApoC2 wala part also, right? So that is something you have to remember. So let's see what is given in your answers. Yeah. So they have already given the lipoproteins. We have chylomicrons, very low density lipoprotein, and high density lipoprotein. So we have plasma lipoproteins, which are separated by electrophoresis. So yes, these are, yes, you already know, we have already discussed chylomicron, VLDL, LDL, okay, HDL, right? And the free fatty acid, that is the albumin complex. Now, the protein part of lipoprotein, it is also known as apolipoprotein or simply apoprotein. I've already discussed what is the protein part present in each thing. So in chylomicrons, the protein part is ApoB48, ApoC2, ApoE, right? In other, you already know the very low density lipids, we have ApoB100, ApoC2, ApoE. In low density lipoprotein, we have B100. In high density lipoprotein, we have like ApoC2, right? We have ApoE, ApoC2, right? So that is something that you have to remember. Okay, that is about the lipoproteins wala part. The describe different types of lipoproteins. So we have already discussed all the different types of lipoproteins over here. Now, again, you can see the chylomicron is having the biggest size, but it is having the least density, guys, right? Why? Because it is having least protein. HDL is having high density. Why? Because it is having high protein, right? So actually, the density of the lipoprotein basically is directly proportional to the protein content. Protein content. So more protein content, more density. So obviously the HDL contains more protein content as compared to the lipid part. Whereas this chylomicron, basically it contains maximum lipid and least protein. Least protein. So that's why it is having least protein. So it is having the least density, right? So that is something you guys have to remember over here. Okay. So that is triglyceride, phospholipid, cholesterol, and protein, right? So protein, obviously you can see it is maximum in HDL compared to LDL, IDL, very low density lipids, and chylomicron. Chylomicron is having the least protein wala part, right? So that is something you have to remember. And one more thing that I have told you, that the phospholipid, you can see it is maximum in HDL. Phospholipid part, it is maximum in high density lipoprotein. Phospholipid. So it is maximum in high density lipoprotein. High density lipoprotein. So that is something you have to take care of, right? Now, coming on to this, we have already discussed this, right? So chylomicron, it is containing the apoproteins B48CE, right? Chylomicron remnant B48E, very low density lipoproteins B100 C and T, intermediate B100 and E, low density B100, and high density it is A. High density it is A, right? Now, Now, before that, let us just try to discuss one more thing over here. Let us just try to discuss one more thing over here. Guys, you already know what are these functions of apoproteins. Let us just try to discuss the normal functions of apoproteins first. Functions of apoproteins. Now, I've been always telling you, in addition to the lipid, we have protein, and these proteins are called as apoproteins, right? So we have apoprotein B48, okay, which is present in chylomicron, right? Apoprotein B100 and apoprotein BE, sorry, apoprotein E. So you already know we have these three. Yes, the apoproteins. Now, what is the function of these apoproteins? They help in the interaction, guys. They help in the interaction of lipoprotein with receptor, right? They help in the interaction of the lipoprotein with the receptor. Now, that is something you have to remember. For, for example, let us just try to see over here. Done, guys. As usual, you are taking the dietary fat, you are consuming oil, you're eating so much of fat. Say the exogenous fat. Exogenous fat, it means that this fat, it is coming from outside. You are eating oil, you are eating butter and everything, all the fat is going inside, and it is coming to the small intestine. Now what happens? We have this lipid molecules in the form of triacylglycerol or cholesterol, right? So now what it is nothing but the triglycerides, or it is cholesterol, what you are taking from outside. Now what it will do, guys? Now this triacylglycerol, or I can simply say, now let me just write down in this way only. Now guys, let me just try to show you in a very simple manner that let us suppose that this is triglyceride or triacylglycerol, one of the same things. or guys, it is cholesterol that you have consumed from outside. Cholesterol. Now what it will undergo change? It will in the blood. Now let us just come to the blood. In the blood, it has entered into the blood. From the intestine, it is going into the blood. Now in the blood, we have the three important proteins which are present over here. We have this ApoB48, ApoE, and ApoC. We have these three lipo. We have these three proteins, guys. Now, guys, you already know we have the lipid, we have the protein. Together, it is called as lipoprotein. And which lipoprotein it is? It is chylomicron. Let us first take it is a lipoprotein 1 that we have already discussed. It is chylomicron. Lipid part क्या है? Triglycerides and cholesterol. Protein part is ApoB48, ApoE, and ApoC. Obviously, they will combine and this will result in the formation of lipoprotein. Now, what is the function of these proteins? Obviously, they are making it soluble or making it transportable in the blood. Now, what will happen? These proteins have a unique feature of identifying the peripheral tissues. Identifying the peripheral tissues. You already know peripheral tissues. I'm talking about the adipocytes, right? Now, what will happen? These adipocytes have a receptor present over here. These have a receptor present over here, right? These have a receptor present over here, right? Now, ApoB48, ApoE, and ApoB100 also, right? What is the function of these three? Basically, they actually identify, okay, the interaction of lipoproteins with the receptor. So this is something that you have to remember. Now, you already know this is the adipocytes, right? This is the adipocytes, right? So you already know, yeah, they are having these receptors. And to identify these receptors, basically we have these protein molecules ApoB48, ApoE, and ApoB100 also. Since I've taken chylomicron, that's why I'm not writing ApoB100 over here. Right, ApoB100 over here. ApoB100, it is in very low density lipids, right? Apart from that, guys, remember the ApoC. Yes, the ApoC basically stimulates. Remember the function, it stimulates the LPL. LPL, guys. You already know the lipase part, the lipoprotein lipase, right? So yes, it stimulates the LPL. Now this LPL, this lipase will break the chylomicron, okay? Will break the chylomicron, right? So yes. So automatically a remnant is left, that is triacylglycerol plus cholesterol along with ApoB48 and ApoE. So again, this is called as the chylomicron remnant, which will go into the liver, right? So that is something that you have to remember. Again, that is about the functions of the apoproteins also, right? Now I have to discuss, yes. The high density lipids, the mechanism, it is the transfer of cholesterol esters into IDL and LDL. Apart from that, guys, remember this ApoA protein. Now, ApoA protein, again, it has been asked in the exam that it activates an enzyme that is called as LCAT. I'll be discussing the metabolism fatty acid wala part tomorrow, right? Again, yeah. So it is called as lecithin cholesterol acyltransferase. So this activates this particular enzyme, lecithin, yes, cholesterol acyltransferase. Now, again, if you just simply want to learn with a very simple diagram, if you want to learn what is the composition of low density lipoprotein. Low density lipoprotein, you already know we have triglycerides and we have cholesterol. Now, in addition to that, we have ApoB100. Now, if you want to ask me what is the composition of HDL, it is triacylglycerol plus cholesterol. We have ApoA, right? We have ApoE and ApoC. These are the proteins and these are the lipids. So lipids plus protein, it is lipoprotein. Now coming on to the impaired synthesis of lipoproteins. If lipoproteins are not synthesized, guys, right? Now it can lead to defect in the phospholipid synthesis. I already told you guys, right? I already just mentioned over here that yes, the high density lipids is basically the maximum phospholipids that derive from. So they will be impaired or defect in the phospholipid synthesis. That is the most common reason. Block in the apoprotein formation. The phospholipids are not synthesized, the apoproteins are not formed, or they're blocked, or there is a failure in formation of lipoprotein. Again, the triacylglycerol or the cholesterol, it cannot combine with the proteins present, or there is some defect in the protein. Automatically, it will result in the impaired synthesis of lipoproteins, right? So obviously, if there is deficiency of essential fatty acids or there is deficiencies of lipoprotein factors, right? Those apoproteins, right? So that can also lead to these things, right? So that is something you have to remember, guys, right? Apart from that, the endocrine factors like ACTH, insulin, thyroid hormones, okay? So they all promote the deposition of fat in the liver, right? So yes, that is something you have to remember over here. Now, again, you already know. Now, this is something that you have to remember. The factors which are contributing to increased triacylglycerol synthesis. Now, you guys already know if the fat is increasing in the body, what could be the major reason? If you're consuming high fat, right? You are eating a lot of oily food, right? Junk food, burger, pizza every time. What will happen? A high fat diet will increase in the triacylglycerol synthesis, right? Because the increase in the free fatty acids, it will go into the liver, it will form more THE, right? Or diabetic patients also. I will come to that. Extra glucose no will be converted into pyruvate, right? You already know the pyruvate will go into acetyl coenzyme. This acetyl coenzyme will undergo the beta oxidation, and beta oxidation will again form these, yeah, the triacylglycerols, right? So even the alcoholic patients, they also have this glycerol component, right? The alcohol component, obviously. So that will also result in the formation of THE. Now, you already know if the triacylglycerols are increasing, if it's not metabolized, obviously there will be something called as the fatty liver. We have grades like grade 1 fatty liver, grade 2 fatty liver, right? Or there could be some other reasons that is no contributing to decreased VLDL synthesis, right? Now, VLDL synthesis is decreased due to decreased apoprotein synthesis. Now, it can be no due to protein energy malnutrition or hepatic injury due to hepatitis B. There could be multiple reasons for that. Okay. Or there could be decreased phospholipid synthesis. You already know the phospholipid parts. The lipid part, it is composed of essential fatty acids. If there is low essential fatty acids, automatically the phospholipid part will also decrease. That's the major component of the no plasma membrane. Or there is increased cholesterol intake, right? Or we have decreased lipotropic factors. We have different lipotropic factors: choline, inositol, methionine, selenium. I will come to the lipotropic factors in a couple of minutes in the next slide. So let us just try to answer this. What are the lipotropic factors, guys? Now, these lipotropic factors basically they play an important role in removal of fats from the liver by different mechanisms, right? Now, obviously, if the fat is more, you already know it can damage the liver. It can always there is a risk of no heart attack. Obviously, they will be causing atherosclerosis. The high cholesterol will be no deposited in the blood vessel wall, and they can automatically cause those heart attack scenarios. Now they include the lipotropic factors choline, inositol, methionine, betaine, vitamin E, and selenium, omega-3 fatty acids, right? So obviously, if these factors are not present, right? If these factors are less, guys, so there can be a risk of fatty liver, right? There will be more deposition of fat in the liver. Now, what is hypercholesteremia? Now, guys, let us just try to understand this term. hypercholesterolemia. Now, emia basically means beta blood. Yes. Hyper means increase or high cholesterol in the blood. High cholesterol in the blood, right? So now when I say blood has two components, right? The cells RBC, WBC, platelets, and we have the plasma component. Now, if in the plasma, if in the blood, emia means blood. If in the blood, the plasma cholesterol, it is okay, increasing 200 milligram per deciliter. Then it is called as hypercholesteremia. Obviously, just remember a situation, guys. Let us suppose that this is a blood vessel. It is carrying blood. Now, in this, we have more cholesterols, guys. Cholesterols are depositing over here. Now, if it is more than 200 mg per deciliter, obviously they are providing an obstruction to the flow of blood. If blood will be not reaching the heart, if there is obstruction, then again, it can lead to severe disorders, right? They can lead to some diseases in the heart. Apart from that, guys, it can also, no, diabetes mellitus can also result from increased cholesterol synthesis, right? You already know diabetes mellitus kaise hoga. You already know we have glucose, extra glucose. Glucose converts into pyruvate. Pyruvate converts into acetyl coenzyme A. This acetyl coenzyme A will undergo beta oxidation and no, this can also result in the free fatty acid wala components, and that can also be there. Hypothyroidism due to a reduction in HDL receptors on hepatocytes. Apart from that, jaundice can occur. Obviously, the liver is getting affected, right? If there is obstructive jaundice, now when I say obstructive jaundice, you already know that it's linked to cholesterol excretion. If the cholesterol is not able to excrete from the liver, there is an obstruction through the bile. So that can also lead to this. Nephrotic. Nephro means kidney. Now, nephrotic syndrome leads to cholesterol elevation due to an increase in the plasma lipoprotein fraction. Okay. So I already told you the atherosclerosis, guys. You already know, if suppose this is the blood vessel. Now the cholesterol is getting deposited. So it is plaque formation. That is something called as atherosclerosis. Basically, the blood vessel walls are from the inner layer of these blood vessel walls, the endothelium parts. On that, basically, we have depositions of these cholesterol molecules, and what they will do, they will obstruct the flow of blood. Obviously, when the blood flow is obstructed, the kidneys will also get affected. Obviously, the blood reaching to the heart will also get affected, so it can result in heart disease as well, right? Low density lipoprotein is called as bad cholesterol, right? HDL, it is called as the good cholesterol, right? So, yes. Now, coming on to hypocholesteremic agents, right? Now, this is something, guys, whenever a patient comes to me with high cholesterol levels, right? Whenever a patient comes to me with a high cholesterol level or the cholesterol more than 200 mg per deciliter. Now, this is something which where when we will be discussing the cholesterol wala metabolism, the metabolism of cholesterol, then only you will be able to understand, guys, ki the high cholesterol, it is basically reduced by the help of a drug, and these drugs are nothing but these are called as statins, guys, right? We have various statins. We have rosuvastatin, we have atorvastatin. Mm, Okay, maybe in your family members also they might be consuming these drugs to lower the low cholesterol levels, right? So basically, what these statins do, initially we start with a very high dose like 40 mg, then we come to 20 mg, then at last we do 10 mg. So we start with a very high dose, okay, and then we automatically try to decrease the dose, or we try to taper the dose according to the blood glucose levels. Now, these statins will inhibit one enzyme that is called as HMG-CoA reductase, and this is enzyme which is forming the cholesterol. Now, imagine if this enzyme is reduced, so automatically the cholesterol synthesis in the body will reduce, right? So we have atorvastatin over here. They have written simvastatin, fluvastatin, pravastatin. There are many statins, guys. Rosuvastatin, atorvastatin. So these are something that you have to all remember, right? Now, so that is apart from that is something which you have to remember. Now, again, you already know moderate alcohol consumption should be there, lifestyle modification should be there, exercise, this and that. So high carbohydrate diet, don't consume too much fat. Basically, these things we are saying to the patient, but the patient is not listening at all. So that's why the doctor's market is running so good, because the patient is coming again with consumption of alcohol, with consumption of all the fast food items, the pizza and everything. So that is, and we are again prescribing these common drugs to the patient to reduce the cholesterol levels, right? That is something you have to remember. Now, coming on to the last one, that is the serum lipid profile. Now, when I say serum lipid profile, I'm talking about the blood, right? Now, I'm talking about the blood, or in the blood, I'm checking the contents of the lipids, right? Such as the total cholesterol level. Now, when I say, whenever a patient comes to me, he said, I'm having pain over here in the heart region or something like that. Obviously, all the tests I will do, but I will never forget to check his lipid profile. Okay, this is a very common test I will ask the patient to undergo. I will take the blood sample of the patient and I will try to see all the levels. I will try to see the cholesterol level in the blood, the low density lipoprotein cholesterol, the high density lipoprotein cholesterol, and the triglycerides present in the blood. Now, remember, guys, the total cholesterol should be less than 200. Low density lipoprotein should be less than 100. High density lipoprotein, I have already told you, it is a good cholesterol guide. It is a good cholesterol. So it should be more than 40, guys. Again, if it is less, then yes. For men, it should be more than 40. For women, it should be more than 50. And triglyceride, it should be less than 150. Again, a patient comes to me with a triglyceride levels. If I do a lipid profile, it is 325. So again, it is more in the blood. It should be less than 150. So again, I have to start the patient with those statins drug, right? So that is something you have to remember, the components, right? I have already discussed about LDL and HDL in detail, guys, in the previous slide. LDL, it is called as bad cholesterol, right? It carries the cholesterol from liver to the cells. HDL, it is called as good cholesterol, right? By it carries the cholesterol from the bloodstream back to the liver for excretion. So it is, for example, this is the liver and this is the bloodstream. This is the bloodstream. So extra cholesterol, it is basically carried down to the liver only. So it does not allow the extra cholesterol to stay in the blood. It is taking the extra cholesterol from the blood into the liver and helping in the excretion wala part. So obviously the HDL is very good. If it is more than 40, it automatically indicates it's, yeah, the levels automatically indicate the decrease in the risk of the cardiovascular diseases. So that's all for today, guys. Okay, I have to discuss one more question. Okay, let us just try to discuss the lipid storage disorders. Lipid storage disorders. Yeah. Now, now, guys, I will be actually discussing this in a very short wala part. Let us just try to draw our own flowchart for this first. Now, you already know we have glycolipid. We have glycolipid. Now, glycolipid, it is formed from fatty acid. Any lipid, it is fatty acids plus alcohol. Alcohol, it means the glycerol, right? And glyco means glycogen. Glycogen means carbohydrate. Glycogen means carbohydrate. Now, you already know it can be of two types. If we have fatty acid plus alcohol plus monosaccharide. Monosaccharide. That is also a carbohydrate. Or if we have fatty acid plus alcohol plus oligosaccharide. Oligosaccharide. Now this composition, it is called as cerebrosidase or cerebrosides. And this oligosaccharides, guys, you already know the sugar unit, it is between 3 to 10. Mono, 1 sugar unit. Disaccharide, 2 sugar unit. 3 to 10, it is oligosaccharides. Okay, 3 to 10, it is oligosaccharides. Right? Now, these cerebrosides can be of two types, guys. This can be of two types. It can be fatty acids plus alcohol plus glucose, or it can be fatty acid plus alcohol or glycerol plus galactose. Okay, so this is called as glucocerebroside, and this is called as galactocerebroside. Now, if an enzyme over here that is called as glucocerebrosidase, this will help in the metabolism of this particular lipid. Now, if this is absent, it will result in, okay, if deficient, if this enzyme is deficient, it will result in Gaucher's disease. It will result in Gaucher's disease, guys. Very, very important. Gaucher's disease is due to the deficiency of glucocerebrosidase. Now, glucocerebroside, you already know we have glucose, we have alcohol, and fatty acid. Galactocerebrosidase, basically, it is metabolized by two enzymes, right? We have beta galactocerebrosidase and alpha galactocerebrosidase. So if the beta galactocerebrosidase is deficient, it will lead to Krabbe's disease. And if alpha galactocerebrosidase is deficient, it will lead to Fabry's disease. Fabry's disease. Now, fatty acids plus alcohol plus, yes, oligosaccharides. This is called as gangliosides. Gangliosides. So again, we have two components over here, the alpha hexasaminidase, right? And beta hexasaminidase. Now, if this is deficient, guys, if the alpha component is deficient, it will result in Tay-Sachs disease. If the beta component is deficient, it will result in Sandhoff's disease. So these are different disorders that you have to just remember the names as per se, which is given over here, right? So that is something that you have to remember from over here. So yes. So these are all the lysosomal storage disorders, right? So obviously you can remember this flowchart as well in a very quick manner, right? So you already know we have already discussed the glycolipid part, and if you just go with the enzyme and the disease, right? So that is all for today, guys, right? So thank you for watching. Thank you for your patience. Thank you for listening me out. So we'll meet tomorrow with the new topic. Bye.